So let's start from the left to the right. This is where you set up the material size to start or to put your block. These are the 2D operations, 3D, we'll see this later. Drilling operations, multi-axis, something that we don't have. All our machines are with 3 axes. When they consider multi-axis, here is up to 3, 4 or 5 or even 6 sometimes. Turning is for lathes, automatic lathes or semi-automatic lathes, so we won't use this. Cutting is for lasers. I still haven't used this in Fusion 360. We have a simulation when we create the toolpaths. A post-processor or post-process is to convert the toolpaths we create into something that the machine can interpret. And setup sheet is to open a setup for some machines. You can use inspect and tool library to create tools or tool holders. And this one I never used, task manager. Let's okay. So to start, you click on setup. It generates a watermark cube or box where it fits all the design. In this case, we only have one part, but if it was more than one body, we can come here to model and select the bodies that we want. In this case, it's only one. And also we can define if we have the vice is the clamping system to hold the material. We can also put there, and when we simulate, we see if it touches anything. Okay. So starting again from the top to the bottom, it's a milling operation. The model orientation, we always select the Z. So the Z is already up. So we created the part in the right direction, but we could have made in the wrong direction. So we select Z axis and plane X, and the Z axis, it stays highlighted, and it's waiting for me to select the direction of the X. In this case, it's this face, it's face up. It doesn't change anything, but it could. And the X is always pointed to my right. So in this case, if I change, it's already okay. If I want to build the part like this, I just click on this to put the X on this direction. If this stayed like to the X to the left and Y to the front, it would be wrong. We could click here and it would rotate the axis. After that, you can click on a stock point, several points here. This is where your zero of material stays. Usually you can use the center of the material or one of the edges. It's the easiest point to find on the machine. Okay? Okay. Starting from here, let's define the X, the Z and X. I'll remove this. The Z. Joana, eu vou explicar, tu vês a explicação toda, depois tentas fazer, pode ser? Então, tem aqui, eu vou fazer em inglês para depois os outros acompanharem também. So this, if I want to define the Z, I just select here, Z and X. You have the Z axis. You click the face you want to come up in the direction of Z. So the vertical face. Then the X. It means, let's say, the X in this case would be in my direction. I don't like that. I want the X to be to my right. So I'll click here and it will change the X to my right. Sometimes the software puts reversed the X like it's doing now. The edge. So X is now at my right. And now I have to use the box point to select which edge I want. Try to set up like this. No. I'll tell you why. Because your material is sticking out between devices. You can't measure the bottom edge. It's easier for the probe to touch on the top. Okay? Mostafa? Yeah. Did you understand? So, in one of the machines, the 0 is made with the tool, and the other has a tool probe, or the work probe. For me, after placing the, let's say, the block of material, if I place, let's say my hand is the vice that grips the material, if this is the block, it's harder for me to remove a point down here than up here. So with my probe, I just come here, touch, and see the surface. It gives me the Z0 of my work. And then I can find the corner up here. And this is going to be my 0. In this case, if this is the block, the 0 will be made on this side. Okay? We still don't know the size of this. So we go to the stock tab. It created a relative size box. So it means it adds 1 millimeter on the stock side and 1 millimeter on the top side. We can change this to fixed size block. Let's say we have a block of 60 by 60 by 60. And it puts this in the middle of that 60 by 60 by 60 block. So it means our part is going to be built inside what we already have. Let's say this is a block of 60 by 60 by 60. Our part is going to be inside this. We can't see it yet. Okay? But I need some space to hold the material. So I have my block. I can't hold it with only 1 or 2 millimeters. And I have an extra on the top that I don't need. So what I can do is, here's an option with the Z, model position. I can offset from the top only 0.2 millimeters. And all the remaining comes down here. Now I can grip my work from here. No?
The material that you put in the machine has to be a cube 6066.
In this case, yes. If this all depends on what I have available. If I only have a block of 100 by 100, I would have to put 100 by 100 here. So let's say my block is 100 by 100. This will happen. And I have to remove all this material.
Yeah, but you want to save material. You want to save material, so you don't want to put that in the middle. You want to put in the corner and use the material for something
sometimes you can't you can't do that because you need
cut.
yeah you
the
can
size
cut
you
the
want.
material to fit only your part, just to not to spend as much material as it should.
But in my case, this box is bigger than my actual product one. It's like this.
The box has to be bigger than your design.
It's quite bigger. Yeah.
Okay. Can you come to stop? Because you still haven't changed this. So
If
stock fixed size
yes, if I do that, it goes outside. I already done.
goes outside. Okay. Try this.
So it's same size, but it's outside.
Okay. Try this. Here, the model. Just click on your model. Here. Remove what you have, and then click your model and see if it solves the problem. You just need to select the body. It's inside now?
Yes.
Now you have to come here and put fixed size box and choose 60 by 60 by 60, and I want an offset from the top of my Z of 0.2 millimeters.
I just said why you want to offset.
If we want to keep the size of 60, I need more material down here to grip the part. Joana está ali do tipo.
Because
O que é que ele está dizendo? Percebeste, Joana? Um, this is not enough for the size of our part, but we won't change that now. I'll tell you after. So after this, you can put OK. The box is created of our material. As I said, there are some features that we cannot do with our machines. And one of them is this little hole here on the side. And why? Any idea?
It just goes from top to down.
Exactly. So if I have my block and the machine only moves the table and this down and up, I cannot pull the end mill or the drill to this side. I needed one more axis to rotate this and drill on the side. Okay, that's why we haven't used, but we do have the fourth axis. We can hold the material like this, and I can rotate and do 4 faces. And if this is small enough, I can also do this part. In this case, with 3 axes, we cannot do the side hole. I just left this here to show you. So let's try to machine this now. Only with 2D operations. First, there's a facing operation. So facing is an operation where it flattens the top. It opens this menu. All the menus for every operation are the same. They have the tool, geometry, height, passes, and linking. In this case, we'll choose the tool. I already have some tools defined, but you have also the sample tools in inches and in millimeters. Also for different materials, if you can see bronze, copper, high carbon steel, low carbon, plastics, stainless, titanium, aluminum. So our material is aluminum. Since it's a facing operation, uh, try to look to the biggest tool you have.
Sample metric aluminum or inch?
Metric aluminium, sample metric aluminium. And in this case, they don't have a face mill. They only have on metric. You can filter the type of tools. Okay, I'll give you a small introduction to type of tools. Um, uh, so face mill. Face mill usually are this kind of tools. They have different and a lot of inserts that cut the metal. Usually, they're used to remove a lot of material in a big area, and this is considered a face mill. They have different configurations also. So, face mill or facing mill. Then the general flat end mills. Why it's flat? Because as you can see, the tip is flat. Some of them are considered bull end mill because the edge has a small radius, so it gets a little bit rounded when machining. The next one is a ball end mill, easy to understand because this is looks like a ball. They have also different radius. Chamfer mill. Does anyone remembers what is a chamfer operation? A 45 degrees or 60 degrees cut on the edge. Also used to sink the screws. There are screws that has an angle. You use this to put them flat on the surface. This is a drill, simple drill. I think everyone used a drill before. Wood, metal, concrete, different types, and a uh, drill, thread drill. Some of them are by hand, others can be used on the machine, others can cut the hole and make the thread at the same time. There's a lot of threaded types and tools. These are the main ones. We can see here ball, bull, flat, face, tapered. It's another kind. Boring is for lathe. Radius is when you have furniture at home with the round finishing. Usually the carpenter does that. It's used as a radio tool. Chamfer I already told. Dovetail is to make inserts. Uh, it has like um, it's like the back of a dovetail. I think it's an animal. So sem andorinha, rabo de andorinha. Uh, I don't know. I think this is to create os vincos. É para criar vincos mesmo. Sorry, I can't translate but we won't use this. Don't worry. Slots, just to create a slot. thread, and the probe. And then there is a drill, center drill, spot drill, reamer, countersink. These are all specific. Center drill is to make the hole before you align with the drill. Also the spot drill. The reamer is to make a calibrated hole after doing the drill. And all the others are for lathe and plasma cutters. We don't need it. So let's say we're going to use the 50mm face mill. You can. This is just to filter the type of tools. Just click on the face and use this one. Place OK. You'll see a small shadow of the tool. Now there's also flood. Mist is the type of cooling system we have on the machines, and then it creates feeds and speeds for cutting the metal with this tool. This is already stored. This is only a sample, doesn't mean this is right for this material. Then we jump to the next geometry. Okay, select the tool. Here on the samples has to be on. Just leave the face on, and it will show the 50mm face and mill in the end. And just place OK. It will load this tool to work with. Não tem. Não. Face mill. And try to. Sim. Face mill. Face mill. Face mill. Está no final. Tenta filtrar. Tens que selecionar aqui estas ferramentas. Tens que selecionar aqui estes, os samples. Já apareceu?
Já passou para quantas escolhas depois?
Não apareceu OK.
Não,
Este?
não é esse.
No feio.
Aqui.
Não.
Sim.
Espera, mas espera.
Tem aquela solução do ecrã e tudo.
Aqui, podes fechar isto.
Não é esse. Deixa estar. Está resolvido.
We go to the next step, to geometry. It already selected my contour. As you remember, our part was 60 by 60, and it's basically this yellow square already selected. So we don't need to select anything here. We go to the heights. There's different heights here. Retract height is how much he pulls the tool up as a safety to move to other places. Retract clearance and retract. They're almost the same, but one is for clearance, as it says, and one is how much it pulls up from the stock top. So you have the stock top, and it pulls up 5mm. Then feet height. This is when the tool goes up to move to other place and cut again in the same operation. Top height is when where it starts cutting, so it's in the stock top, and then it stops cutting at the model top. So we know we have 0.2 from our stock to our model, but here you can define offsets to 0, but one is stock top and the other is model top. It's different. So it's going to remove 0.2 millimeters. Okay? It doesn't show here.
Shouldn't it be more than bottom?
No, because we only want to face and calibrate the parts, or it will remove everything. Okay? So if you want to, we can test that. I'll leave it like this, and then I'll change to model bottom, and you'll see what happens, okay? Okay, passes. Tolerance is how many points it creates on the toolpath. So this is kind of resolution. As you can see, they explain loose tolerance, 0.1. It says from one point to the other, there is a difference of 0.1 millimeters. But if I reduce the tolerance, it makes more points to create that trajectory. So the difference is having 3 points for this trajectory or a million points for the same trajectory. Okay? And this represents the quality we want for the finishing. In this case, it's not important because it's only a facing operation. We're removing a lot of material, so we don't need a good tolerance. We'll leave at 0.1. It helps to calculate a lot faster. Okay? Pass direction. This means you can cut from left to right or from the front to the back. You can change to 90 degrees later to see the difference. Pass over extension. It means the tool has to come out a little bit off the material before it touches. We'll put 20 millimeters. Stock offset. It's try to trick a little bit the program to create more material than it should. And step over. It means that if your tool is this size, but only, and this is your material, the step over, what it does is, this is the tool path. Instead of going this way and pass here, oops, I won't design the mini. Doesn't look good. Instead of doing something like this, the step over, this is 50, as we have on our tool, the step over can be reduced to 30, and this will happen. You understand my point of view? It's hard to explain. So 25, half of the tool. And we can make both ways or climb and conventional. Let's make both ways. It's not a problem here. Then we can define if we have too much material to remove on the facing operation, we can use a maximum step down. As the name says, or the explanation, so I can remove only a maximum of 1 millimeter on each passage, then remove another millimeter instead of removing the whole 2 or 3 millimeters. I can set a maximum for the tool to remove. This is the same for all tools. Step down and step over, it applies to all tools. Okay? So in the next tool we're going to define, it's going to show up again. Step down and step over, it means exactly the same. Okay? We're removing 0.2. We don't need multiple depths. It's going to remove in the first one. Okay? Stock to leave. We won't leave any stock. We want to remove everything, but if you want, we'll use this later. If you want to remove a lot of material without having a good finishing, you leave a little bit of material in the end just to make a good fine finishing. That's why in the mask, I took 2 hours to remove most of the material, and then 7 hours just to remove the remaining for finishing, because I left like 0.1 millimeters in the whole mask to be removed. Okay, and the step over in that case was like 0.1 or 0.01. It was really small, that's why it takes so long, and the tolerance was really low also. Linking. This is to define how the tool enters into the material. We can define an angle or a radius to go inside. As you can see, there is a yellow line has an entrance, and the red line has an exit, and the green line is the rapid, how the tool will approach the material. We'll leave it like this, press OK, and it will simulate the tool path. You can already see the lines on what it's going to do. So from here we can go to simulate. There's some options here where you can hide or put the tool path, and the stock. This is our initial material, and our part is still inside that. Okay, if you put start simulating, it's going to remove material, only 0.2, and that's it. This is the facing operation. Stock here, you're right. But Mustafa wanted to remove until the bottom. We'll see what happens. In this case, bottom, stock bottom, or stock model bottom. And the step over, we need to reduce to 3 millimeters each passage. This is what happens. Let's simulate. The white area is your part, and it's going to be removed fully. And it's only removing 3 millimeters each passage. So if you define as a until the model button, you won't have anything. Okay? It will only leave the part where you grip the part. No, when in the simulation, when you see your model in white, it means it's removed.
Oh.
So because you'll see later when you make the simulation, your model stays with different colors depending on what you remove. Let's go back to model top. Okay, only one passage. Now we want to make this circle. For that, we have two operations. Adaptive cleaning, it removes everything around, or you can do a circular. I'll do an adaptive cleaning for one reason: corners. Select a tool. In this case, we'll use a flat end mill. So you can just remove these, leave flat, look for metric aluminum, and use a 12 millimeter flat end mill. Okay. 12 millimeters. Yeah, sorry. 12 millimeters.
12 flat.
Yes. 12 flat. Hand mill, sim. Let's go back to the tools. Up here, it shows what tools we already used on our project. Here, Go to select tool again. These are the two tools we're using right now. Let's right click and edit tool, and you'll open a window
Which one?
for the 12 millimeter. Here you have the type, material. In this case, it's a high-speed steel. Coolant through tool. No. Three flutes. The flutes are the number of knives the tool has. As you've seen here, some of them only have 2 or 3, others have a lot more spirals.
What the one?
Everyone's in this menu. So 12 millimeters. Do you remember the height of our circular profile?
25?
Not 10. 20. 25. The height of our circle. Sim, o cubo aqui é 30. 25. Remember? In our design, this part from this to this was 25. This shaft only has 25. Perfect. We can work with this. But there are some short tools, and for some work, we can't use them because they're not long enough to go there and cut. And this big part we call the holder will touch the part. So you have to be careful if this is long enough to do what you want. If not, and if you have the right tool, you can increase here the length of cut. Let's say 40. And the shoulder also 45. And the body, of course, has to be even longer, 60. Okay, so now you need to have this tool. Tricking the program doesn't mean it's not going to touch in reality. Okay, just to be sure, and you have to be careful. There is different shaft and holders. I'm not going to talk about this. I don't use it. Feeds and speeds. This is really important, but at the same time, it's really complicated. Every material, every tool has a specific speed for rotating. Surface speed or cutting feed rate is the speed that moves through the material, and the plunge is going inside from in a vertical way, also ramp. This is really specific. We won't take time on understanding this on this workshop. And the post processor, the number, it means the position of the tool. If we're using the Haas, we have 9 positions plus the probe. We can define the position here so that the machine can go get the right tool to machine. So if we have a 12 millimeter, we'll put on position 2 for the machine to go there and start using that tool. Okay?
So because automatically you have to change the
No. If you set them previously on the machine, you can come to the software and say that tool is in this position. You can go get there. Okay? It gives you a warning. Only changes the what we've done for this project and not the whole library. So if I make other project, this tool will stay short again. Okay?
So it says yes or no or yes.
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 Yes. And then press OK. We have now a longer tool to work with. And then we jump again to geometry. In this case, the geometry we want to cut is this one.
But you use the lengths 40, 40, 60.
Yeah. 40, 45, 60, 75. Then we go to geometry and select the square. You can also select this one, but the outside. The outside. Doesn't. No, because you selected stock contour maybe.
The following operation are using this tool, but with different feeds and values.
Yeah, each tool has a different feeds and speed. Yes. Okay. Do you have this selected? Geometry. There is a pocket selection. Pocket selection. Just select the square. In this case, there's a red arrow where you can select if we cut from the outside or the inside. If we cut from the inside, it's going to remove the circle. So we need to cut from the outside. Or let's try something. Yeah. Forget the square. Put the circle. Sorry about that. The blue area is the material that it's going to be removed until that height.
Sorry.
Do you have this one selected?
Yeah.
We'll go to the simulation and you'll understand what part of the material is going to be removed now. Okay?
My corners are round. The corners are round.
Here? Doesn't mind. Heights again. It makes everything automatically unless you want to make some changes. Passes. You use 3D maybe. As alturas podem ficar iguais e voltamos às passagens. Let's consider this a tool with all the knives here to cut. It rotates clockwise to cut the material. It has a cutting height we define as 40, and we can't go over that to cut, but we can use the top part to go deeper. Won't touch. I'm saying this because most of the times when people start machining, they activate multiple depths and use only the tip of the tool to remove 1 millimeter the whole area. Let's say this is 12 millimeter, they will use 1 millimeter the whole 12 of the tool to remove material. That's the wrong way of doing things. If the tool has 40 of height of cutting capability, we're trying to use the whole 40, not wear only the tip. So what we do is, instead of going the whole tool and remove the material, we're just going to define 1 millimeter or even half of millimeter on the side of the tool to remove and make a lot of passes and remove each time it passes, but the whole height. Instead of having 1 millimeter doing this, again the same millimeter doing this, the whole diameter of the tool. It wears too fast. And we'll see on the simulation a little bit better this. So again, tolerance, we can leave it at 0.1 because we're going to make a finishing pass after. Optimal load. In this case, instead of step over, just as a reminder, step down and step over. Step over is on the sides, step down is on the bottom, or height. So optimum load in this case is the step over. So instead of, as you remember from that design I made on the board, the diameter of the tool and the step over is how much you're overlapping the tool. In this case, it's optimal load. And we're going to set up as 0.5 millimeters. From a 12 millimeter tool, well, let's put it 1, it's faster. 1 millimeter of the 12 millimeter tool. Multiple depths. In this case, we don't need multiple depths because we can cut 40 and this is 25. So we won't need the multiple depths. We do need stock to leave because we're doing this really fast. It's not going to leave a good finishing. So we'll leave 1 millimeter has radial. You can see here what's the difference between radial and axial. If you leave both, it's going to leave material on the side and bottom. If you put on axial, it will remove the sides but leave on the bottom for the finishing. And there's also leaving here some and removing all of it here. In this case, we want axial to be 1 and radial 0. They don't let us do that. Let's leave 1 on each. Then we can make smoothing, tolerance, and some feed rates for optimization. You can select this or deselect. It changes on the corners, the approximation of the tool on corners. Then linking. We can leave this as it is. Okay. And it created a toolpath. Now to see the simulation for this. Click here on the setup and then just simulate. You have the first tool and the second tool. You can do individually, but you won't see the previous operations. And you can get an error, or you can simulate everything. And this is what is going to happen. I'm using the side of the tool to remove the material and not only the tip. It removes the square, 1 millimeter each time. And then when it gets... not the simulation, but here you can see the time. Statistics, machining time, 2 minutes. But this depends on the feeds and speeds you put on the tools. And it's really close to what they give. So you actually know how much time it's going to take to do this part. So we have a circle. Let's try to use circular now. Select the same tool, 12 millimeters. Okay. Geometry, the circle. A mesma ferramenta. Then we jump to passes. And it removes the multiple depths. And just 2 step overs or 0.5 millimeters. Sim. 0.5. 2 de 0.5. Ok. So same tool, geometry, the side of the circumference or the cylinder. We don't touch the heights. It's okay. In the passes, I put multiple passes of 2 stepovers, each one with 0.5 because we left 1 millimeter, and I want to remove even less this time, 0.5 each passage. The whole tool again. Climb operation. It means it's going against the material. It's the best way to cut. Deselect the multiple depths because I don't want that. And stock to leave, it's also deselected. Now I want to remove everything because it's a finishing. Okay. At the linking, we don't touch again. Okay. And you can see the toolpath, 2 passes, we'll simulate later. We want to do this hole with a pocket operation. We just select pocket, the same tool again, geometry, and this time pocket, 2D pocket. It's here on the list, the second one. And now that I have my tool, I'll select the inside profile I want to cut. Passes. Let's increase the tolerance to 0.1, 0.01. Maximum step over. Let's put 1 millimeter. Let's remove stock to leave. We don't care about the finishing in this case. But now we have a problem. We don't have an entrance place. So it means when your tool gets there, it's gonna get the full diameter of the tool to cut. So it needs to create some kind of different entrance for the tool. In this case, it's going to make a ramp or helix ramp type. We can change it. We won't change in this case for the entrance, and we'll see what it creates. It creates a warning. Perfect. Too small to reach. This was... How much was this? 20. 20. Ele calculou a rampa. Ok, vou fazer de novo.
Mas eu tenho tudo para vermelho.
Não pode estar a vermelho.
Tudo para ficar vermelho.
It's too small. Eu penso que isto é por causa do ângulo de entrada. In which one? I left, yeah, I placed 1 degree to see if it fits. This is... It's okay. It generated the toolpath. Ah, é a vermelho. Não, não, é a vermelho. É a vermelha entrada e depois fica azul. que é quando começa a retirar material.
Para a fase crítica, jumping,
Esta dentro. Esta aqui.
Sabe que coisa que eu digo? Estava junto da mesma dimensão.
Mas não deixaste os 20.
Eu já não confio naquilo que eu
Faz o inspect. Se faz favor. Isto tem a ver com o tamanho da hélice.
Eu tenho 25. O cerco que tem. Se é esse.
Pronto, já está. Como é 20,
O meu 25 passou.
since it's 20 and the tool is 12, you need to put a helix ramp diameter smaller than the sum of them. You understand? 12 plus 8, 20. That's why it makes the ramp in this case. Did you understand why?
Yeah, because the dash
Of the tool?
Yeah.
And if the ramp is too big, it doesn't fit. We went back.
É, só tem que mais um tapado. Ou seja, o último está tapado, depois é 8-0.
E o 8 tem verso, tá?
O 8 deve ser.
0, 8, 0, 8. Ok, não dá um 0.
Não, está a primeira esquerda.
Parece uma boa coisa.
Faz as linhas. Já parece que não. Ou seja, estás a ver como no fundo já está azul. Se eu não está a dar, o que é que tu fizeste? Esse aqui é mais complicado.
Certeza se não dar, só são. Deixa eu para a máquina. Elas todas também vão trabalhar. Será? Não sei se não.
Have you managed to simulate everything? And the result? Se forgot something.
Ou seja, quanto é que tu já máximo de takeover? Ninguém nunca foi.
Na post step over, pôs a.
Máximo de takeover, as pessoas estão.
Espera.
No jogo.
Foi 1 mm, sim.
Let's take all that off the case. Goals.
Every time you use a new tool or a new operation, it has a different color.
Let's take all of the case.
It's the result of all of them.
I'm going to
because it's going to stay with the same format. Why it left these corners? Anyone knows? Não foi só por causa disso. Mustafa, any idea why I have these corners? Na operação, in the previous operation, we had stock to leave, right? That's the stock it left. And in this operation, the step overs we made are not sufficient to remove all the material with the circular pattern. Okay? We'll just leave them there, okay?
So the machine has two places to put the drills because we are using two drills.
It has 9.
9 or 10? Ah, 9.
9 because the 10
It is
plays.
not simulating the time that it takes to change.
Good question. I don't think so. But you can make it in maybe 5 seconds. It will change if it's at 100%. It's really fast. And this can be improved because the feeds for this are a little bit lower than we can do. So for the 12 millimeter, they have a feed rate of 2,300 at 8,000 RPM. We've managed to put at 10,000 RPM and cut at 4,000 millimeters a minute. So it's really fast. The machine vibrates a lot, but we can cut really fast. That's the goal, without breaking the bit. Okay, Joanna is back. Now we're going to make this surface round.
So what the corners? How do you solve that?
Ah, to remove those corners, this is the operation that left a little bit of stock. So in this one, I need to make more step overs. In this case, instead of 2 step overs, or increase here 1 millimeter and make 4 step overs, maybe 5, and it will get there. We can check, pull everything to the end. No, it's not enough yet. Just put 2 millimeters and it will be enough. And in this case, it's going to remove everything. I'll just pull simulation to remove everything.
Where is the option to step over?
Here, passes. Passes on circular. Number of step overs. 5 with 2 millimeters. Just to remove that. Or you can use again the 2D adaptive cleaning and make a few passes, but most of the time it's going to cut nothing. It's going to be empty because the material was already removed. You found?
Yeah.
Let's try to create this surface. For that I usually use bore option. But for the bore option I need a ball end mill. So let's just leave a ball. And let's say that's 20. Aluminium. Here. Let's use the 6 millimeter ball end mill. Six millimeter ball end mill. Okay. For the bore operation. Select. Now I have here, but you can come here, filter only the ball end. Okay. Look for metric aluminum and 6 millimeter ball end mill and press OK. Metric aluminum 6 millimeter and ball end mill. Then we go to geometry. and we select this up. Now I'm in trouble. I'll just try here something. Selection. Not working as it should. Sometimes you have to adapt your operation depending on, sometimes it works, sometimes it doesn't. Let's try thread. This would be stupid, but no, can't be thread. This is weird because I already did with this, and the image shows that you can use with this on this surface. This is not what I want. Okay, let's jump to 3D 3D cleaning. We have some of them are similar to what we have here, and others even better. For this, let's try to use scallop and use from here to this point. Or sorry. Let's start selecting the tool. 6mm ball end mill. Yes, the same tool. Scallop on the 3D. Use the 6mm ball end mill. Choose the geometry. In this case, from here to here. So it's two selections. This one and this one. I don't care about the slope. It's going to look for the surface. Touch surface. This surface. This is 0. Try to put the same selection as I did.
Why? No, I was really easy.
A geometria. Estás usando o scallop. Passes. I don't care. Step over. This means, so if we're using a 6mm ball end mill, we'll try to step over 0.1 millimeters. So it creates a much smoother surface difference between passes. So step over 0.1, only one way. Upcut, up or down mill, I don't care. We won't leave any stock. And the entrance, it's okay. Let's see what it does. This is gonna be a problem. Linking? I didn't change anything.
It has 2 points. Mine has nothing.
Perfect. You don't need. That's entry points. My mistake. So if you click OK, you're gonna get the toolpath. Dá um erro? Por que dá um erro? O que é o warning? Perfeito. Não criaste bem a seleção.
Não, não é aquilo que eu fui tentar. Todos vão fazer o erro. E no geometry, vocês duas linhas. Ok. Face 0 níveis de acho.
Sim. Que é mesmo para decorar.
Agora nem pelo menos apareceu. Mas ele foi com material só a trinha de 100 mil. Tipo, ele vem de 100 para baixo.
Tem a ver com este. Inside, outside, don't care. Direction one way. Don't care up or down milling. E o step over 0.1.
Espera, em cima 0.01, don't care. 0.1, one way, don't care. Não, tem igual.
Fecha e faz outra vez. Selecionaste aqui a face. Esta face.
Se o puxa faz uma trilha, estás a ver o verde sempre?
Sim.
Se faz meio.
Olha, isso tem que
Selecionaste estes dois. Ou selecionaste o de fora e o de dentro.
Lúcio, dessa parte, do avoid touch surface face, deixa de andar aí. E o facial.
Tá bem. Let's simulate this and see. This takes 8 minutes. This will probably break the end mill. Anyone knows why? The end mill, the ball end mill. Any idea why? I'm making the simulation to see if you can understand what's actually happening. Or maybe I'm wrong. It might not break because we're removing a really small amount of material, but there's a possibility. Because if you noticed, I didn't remove most of the material here of the center. Let's try to finish the simulation. Okay, it's finished. Almost. This part here has a lot of material to remove yet. And this should be removed, most of it, before I do this operation. Doesn't mean it doesn't work, but it's better to reduce the probability of this happening. So what I could do is to use an end mill to enter from the center and remove this material first on the area of the bore, and then use the ball end mill. We'll just leave it like this because we're removing a little amount of material each passage. So we are almost there. It's calculating. Every time you pull the here on the bottom, it recalculates everything. This is our part. It's getting really close to what we want. Let me try to use the bore on the outside and see if it works. I don't think so. No. So You can do the same to the outside. Use the 6mm again. This is the top. No. Selection. This is the top. This is the bottom to make the other fillet. You can touch the surface. Doesn't have anything. I don't care. Basically, I don't care. Sometimes it's useful to choose, but depends on how you build your part. That's it.
And also, it's from inside out or from outside inside.
I don't care in this case.
I can select either way.
Yes. In this case. Might be useful on others. This 0.1. This might not give you a really good finish because it doesn't go all the way down. You might need to define the height a little bit lower for the bottom. It looks like it's doing everything, but okay.
Avoid touch surface.
You can select or deselect. That's
Select
I'm not sure what it does. Yes, everything? No, that can't be. You selected the. Maybe you touched on the model and it selected everything. I only want this face. You can click on the X to redo what you want. These operations are really fast to calculate, but sometimes I wait for 1 hour, depending on the size I want. I already left my PC calculating a toolpath for a night. We were doing a 1 meter by 150 maquette, architectural maquette, and I was using a 1.9mm tool to pass on every single point of the maquette. That's why it took 27 hours to make that final pass on the T-Rex. And that's why it took like 6 or 7 hours to calculate the toolpath. Okay, we've done the part. And we cannot machine the bottom part. Why? I don't have a long tool to reach this part. I would have to rotate my block and start from this part and machine the square. We won't do this. The principle is the same. You have to lock your block, calibrate on the machine, and just make a contour on this block. But we have a hole here to make. Let's make a drill.
the last scallop. I have two warnings and the machine area and the toolpath.
It's really hard from here to know exactly what happened, but you have to confirm if you place the right edges, the right surface. The step over, if you put a step over bigger than the space you're doing, it probably doesn't find anything. So probably this is a fillet of 1.5, and this as a standard stays at 3mm, half of the tool.
It's both ways.
Yeah, I placed both ways. And I didn't touch on the linking. That was the problem? The step over? No? I'll help you.
The boundary overlap is complete.
Yeah, boundary overlap.
Avoid touch surface 0.
Yes, and touch surface. Okay, let's make a drill. Click on drill, select the tool again. In this case, I want a spot drill. Just leave the center drill, sorry, center drill. There's only in inches. Let's use the smaller one. Yeah. Okay, let's use the 1/8 inch.
It's inches.
Yeah, 1/8 of an inch center drill. Okay. Geometry. I can't use this. The tool is too short. I wanted to center here the hole, but the tool is too short to go down on the hole. So we'll just drill what we want. Selection again. Here, just leave the drills on. Aluminium. Look for 8mm. There's a lot of them because they usually comes in increments of 0.1 millimeters. Okay. I want flood also. You found 8. You found the tool. 8mm drill. Aluminum. You found the 8mm?
It's not exactly.
It is. There is the metric size. Not the center drill, sorry. It's the drill. The center drill can't fit on the hole. That's what I was saying. Let's find the drill. Use the filters to find the drills. Joana. Vai falhar. Tá bem. Tens de pegar na barra, a meia tabela. Já encontraram? O Mustafa encontrou? Okay. Geometry, you select the hole we have to do. If you have more than one, you could, with the same diameter, select the same. You can use this option. Instead of selecting each one, just select same diameter. It will find the same. And you can order by depth or by the number they created. It creates in the height. Yeah, only one hole. Yeah. We don't because we only have one. But you can define on height. If you put the same, it will find another one beneath. It's gonna select it's gonna find like two holes. It's weird, but you can work with the with the planes here and make it go deeper than it was defining. Okay. Also, as you can see, the drills have an angle here, and if we want to drill through, we need to avoid this. So we need to drill drill tip through bottom. Okay, and now it goes all the way. White drill tip through bottom. The last one is not passes, but it's cycle. So there's different kinds of drilling techniques. One of them is peck drilling, or usually it's chip breaking. Chip breaking here, or peck drilling. Where is it? Drilling is a normal drilling. It goes all the way and then comes back. Chip breaking is a partial retract. It goes a little bit, pulls a little bit back, and goes again, pulls a little bit back, and goes again. It's good to clean the chips to remove from the hole, and then it just starts. And this is what we can define. The peck depth 2 millimeters goes back 2 millimeters. We can accumulate until 20 millimeters or reduce this. And the dwelling period is how much time it takes to go back, if I'm not mistaken. Yeah. Okay. I left chip breaking and I didn't change any values here. And we can simulate the whole part and see the result of a finished part. I don't have my tool here, but I can put it. I'm going really fast. The whole part will take 15 minutes. How much time we took to prepare? We took around 1 hour and a half to prepare the part. Of course, with experience, you know which techniques you apply, and this gets a lot faster. But if you're going to do this too fast, you'll make mistakes and damage the machine or break bits, and that's not what we want. And why didn't drill? Or did? Ah. See what the drill has done? The pecking method. It went down 20 millimeters, came up, then went down the remaining. And we have a exactly the remaining. We can't see the hole because we have the remaining block for holding down there. Okay, so our part is here and that doesn't go through. We needed to rotate this and face it to see the hole. Any questions? No? Just a few more things. If you want to machine this part, you can create a new setup, set up everything as the same way, the X the opposite way, box point, This has to stay with the same size.
Breaking, it automatically go out. It's supposed to come out completely.
Yes.
Go up a little bit and go
What?
down a little bit.
Yes.
But
Yes.
it doesn't come out completely.
Because it finishes. It finishes the simulation. So the packing method. So the packing method does this. Deixa eu te buraco.
Você quer dizer?
Ele faz o seguinte. Ele desce até aqui à ponta. Depois ele sobe este bocadinho.
Ah,
Depois desce o resto e sai completamente.
eu pensava que ele tinha esse daí através de tudo.
Não. Podes definir para subir tudo, mas não faz isso.
Não, na verdade.
Neste caso não faz isso. Ok. Ora bem. Neste caso eu podia fazer uma cópia deste. I can make a copy of this. When you make a copy, it makes everything the same way or duplicate. But in this case, the second setup, the Z is reverse. So this is the Z and the X is this. This is my box point. This was, now I have to change to offset Z button to stay with the same material I had previously. Okay, because I flipped the Z, now I need to put 0.2 millimeters on the bottom. We already removed to lock on the vise. Now the vise holds the circle. Okay. What I need to do on this one, a facing operation with a face mill with this stock. I'm doing a little bit faster because I know everyone is tired and wants to go.
Go slower.
Okay, so facing operation, choose the tool, a face mill. Okay, go to geometry. I don't have to select anything because it already defines my material. I don't need to define height. The passes, I only put multiple depths of 0.5 because this time I have more material to remove than last time. Last time it was 0.2. In this case, I think I have 3 or 4 millimeters. Step over again is 25. You all remember what is step over at least, right? Or I need to make a drawing again. Pass extension. Let's put 20 because to avoid the tool from coming up and touch the material, it should touch from the side. This type of tool. Linking. Let's leave it like this. It will create the toolpath. It's okay so far? Simple. Now we need to machine this part around. We have around, this is a 50 by 50 and 60 by 60. So it has 5 millimeters on each side or around the square. What I can use is a contour, but in this case I need to remove too much material. 5 millimeter. The contour only goes through a path, doesn't make step overs. So we'll use again the 2D adaptive cleaning. We'll choose the 12 millimeter again and select this geometry, and it removes everything around the square. The passes, optimal load, the 12 millimeter flat end. When we go to passes, optimal load 1 millimeter, no stock to leave, no multiple depths because this is 30 and my tool is 40. I'll use the side of the tool again to remove 1 millimeter. And I'll increase the tolerance because I'm only doing one passage. I don't want to make the finishing. Which one?
0.01.
It decreases the tolerance. Yeah, decrease 0.01. Yeah, I can leave this exactly the same. Okay, and it will simulate all the parts. Facing operation, a little bit faster. And then decide to create your cube. Why it still doesn't show the hole? Because I didn't select the other one. If I simulate both, so I'm working like this, really fast, and then have to slow down a little bit. Almost there. Sewing the outside. Okay, I'll reduce now. Holes. Then I flip the part, start the new setup. And there it is. Okay. And this is the only thing I can't do. Unless I rotate the piece again and start from the top, just to make the hole. Okay? Yeah, the rotation of the part is always manual. Other machine? No, this is all done on the Haas. Always the same machine. You just have to flip the part manually. Yeah, you always have to align the parts. That's the hard part. That's why if it was me, I would start by doing the top part because it's square, and then it's a lot easier to flip, put on the vise, and do the round stuff. Okay?
That's why you have problem with that hole.
No.
Because
But this block won't be against the vise. I'll use spacers. Tem umas paralelas que fica espaçado e tem espaço por baixo da peça para furar. You have space. If you use spacers, you'll have space between the part and the vise for the drill to go through. Okay, it doesn't touch the vise. There are easier way to do this. I'll create a new setup.
just one thing.
Yeah.
Why was the geometry, this last geometry, why was the plan between the cube and the cylinder and not the plan at the bottom of the cube.
Não sei se percebi.
Yeah. Why did you select that one in geometry? When you select the geometry, you select that line between the cube and
Este?
yes.
Porque é o único plano que tenho que estar virado para o Z.
But why not this one?
Porque o Z ia ficar para o fundo. E quero fazer a parte de cima.
But this Z is wrong, right? This Z should be in this should be the opposite.
E não vou fazer o furo. Não vou fazer o furo agora. É isso que tu estás a dizer. O que é que tu queres que eu faça aqui? A parte de cima ou a parte de baixo?
Parte baixo.
É a parte de baixo. Aí sim, tu tinhas de definir o Z para o fundo. Este Z tinha que vir para aqui.
Ok. E agora na geometry? Vais mudar isso com
Sim.
2D adaptive?
Sim, mas eu não quero fazer isso agora. E já tenho isso preparado nos outros dois. Isto é um novo. Imagina que vou fazer uma peça nova. Este já está aqui, os dois. Está bem? Tens aqui um e aqui outro.
Certo. Mas eu não percebi no segundo porque é que escolhes aquele plano do meio e não o plano do fundo.
Porque se eu escolher do fundo, o Z vai para o fundo. E eu quero o Z para cima. O Z tem de ser sempre para cima. Eu quero fazer esta parte de cima. Se eu escolher aqui o plano do fundo, eu tenho que vir aqui e inverter o Z para cima. E depois eu puxo o coisa para cima. Dá mais trabalho. Não achas? Continuas sem entender. Eu quero fazer a parte de cima, este cilindro.
Não, mas o que tu queres fazer é eliminar a parte de baixo para ver o bem.
Não, não quero. Não quero. Agora não quero.
É nessa parte do
Ah,
nessa parte,
mas isso eu já fiz aqui.
sim, porque é que escolheste? O do meio e não o de cima. Na geometry.
O do meio.
O plano do meio. Vamos dizer aí.
Não, neste eu escolhi o de cima.
Ah, é o de cima.
Sim. Não, neste. Vou confirmar, vê. Aqui eu escolhi o de cima.
Ok.
Está bem? Eu não estava entendendo, desculpa lá. Ok. Qual a vantagem de usar... what is the advantage of using the 3D adaptive cleaning? I'll show you. 3D adaptive. I can use the 12mm. And geometry. I want all the setup until here. The bounding box. You can find down there what the difference between a bounding box, a silhouette, or a selection. So I want to remove all the material around the shape and not only the shape. So I'm using, I've chosen this, but I can remove none, leave it to none, and remove this. It will remove all the stock contour. Rest machining is when you have several 3D operations, you can move, you can see the source from the setup stock or previous operation. So if I'm removing, let's say, marker again. I have this square, I have this, and I have really a lot of details inside here. Instead of starting with a small drill or small end mill and remove just a little bit of material, I can get a big one like the 12mm, remove a lot of this. I'm gonna remove this. Then you'll leave some stock to leave option. If I use a 2D operation, what it does is it calculates again with a small drill or a small end mill, everything, and already it doesn't have material there to remove. So there's an option only on the 3D options. It's from previous operations. So what it does, it calculates what material was already removed from the sides and only remove the remaining. That's why it has the option from the previous. For the first one, of course, you can't use the previous. You'll have to put from the setup stock and use this model. Up. Not the face, but all the model. In this case, it's good to choose your planes because it's going to remove everything. So in this case, my tool is not long enough. I'll use the 25 plus something. This is 30. I can put it 20. 25, 45. No, too much. Let's place it at 26. Again, optimal load is the step over. I'll use 1. Stock to leave, I don't want. Step down, I can go down to 40. And linking, I can leave like that. And this is what it calculates. Doesn't go all the way because of the linking. This has to be 8. Every place that the tool fits, it's gonna remove. 12 millimeter. In a 3D operation, I can basically remove everything I want in only one operation. It looks for all the profiles in my part and removes everything in the same operation. Inside, outside. Sorry?
Why you didn't use this one from the beginning?
Because most of the times the others are enough. This takes much more time to calculate for bigger models, and the probability of an error here is a lot higher. Not every time the computer knows everything, so you need to be careful with this kind of operations. And as you can see, most of the material was already removed in 1 minute and 39. And then I can use a smaller one to remove another pass if I leave stock to leave, or if I put stock to leave, and then a finishing pass. And what we take 2 setups and maybe like 1, 2, 3, 4, 5, 6, 7 operations, 8 operations you can do in 3 operations. Okay. If you want a description on each operation, you just hover on each one. It will give you a sample of what you can do with it. I've used most of them, not all of them. And that's it. This is everything I have for you on this workshop. I hope you've learned a lot. I hope you come and ask stuff, come and build stuff on the workshop. And we're trying to create a smaller workshop, not 8 hours, but around 4 hours, with 4 or 5 people each time to work with the machines and apply the knowledge we learn here.
Where can we buy the
Só material in Cancela. Casa Santo Antonio doesn't sell that equipment. Só material has aluminum and also nylon. You don't need to work always with aluminum. You can use brass, cobre latão. We can use wood, but only on the T-Rex. The Haas doesn't take any wood inside, or it will start rusting even more because we have a high humidity inside the room. It's already rusting some parts, at least the vise and the cones. That's a problem. We can't solve it because we can't control humidity in this case. We don't have any ventilation in the room. Sim, mas é muita umidade. Mas o problema é que quando está a trabalhar aquece muito e evapora muito. As salas têm que ter ventilação. O desumidificador não resolve. Isso já é um problema estrutural do edifício. Ou então financeiro, porque eles não fazem manutenção do ar-condicionado. Não sei se têm mais alguma questão, se querem colocar mais alguma coisa. Espero que tenham gostado. I hope you enjoyed the workshop. You learned a lot. You'll practice this every day.
Could you send us an exercise to the home, TBC? No, you send to our email an
Yes.
exercise. So we can practice.
Yes, but I need to put here. So Anna is so Mustafa. I'm writing the names so I can send email later. I can try to find a simple part to generate on Fusion, to create on Fusion from scratch. And for you to try to machine with some tools, I'll give the requirements and the tools available. You can prepare. Maybe if I organize well enough, we can reproduce those parts on some of the machines later on the next workshop. I still don't have a date. I have almost everything ready, but I still don't have a date because August is complicated. Most of the people are on vacation, so I'm not sure if I put on August or leave it for September, beginning of September. I'll have to think about, and I'll send email, or Daniela will send email to everyone. For the exercise, I can set up something for you to try, and then you'll. I think I have most of the projects already shared, and I can check up later how it went. Okay. Thank you for coming. See you around.